So, hello beautiful people, future me, welcome to another programming workout. First thing we will do is the typing. Choose one of the exercises. Maybe I should have it bigger. Well, I'll leave it as it is for the time being. What we are doing, Haskell Monad. Okay, let's do it. Alright, so, and I forgot about my time. Never mind, so we can fix that. That looks about right. And 3%, that is awesome. Awesome possum. Okay, I tried to focus, but I also had different posture right now, kind of standing straight. Oh, sorry for the slow brain noises. Well, I kind of feel okay. So for how long? 4 minutes I'm recording, but I'm in the mood for our next lesson. I'll use this time. Oh, yeah. Oh. All right, we got something. What is the result? The result is pretty neat. 5%. So I'll keep this down, hopefully, and see how it goes. So I'll close this. And normally I will choose randomly, but now I'm giving priority to the execute program since I'm paying for it. And on the execute program.com, we have some reviews available for the SQL, which I can learn. Okay, so let's go to the SQL and start a review. So, taken lessons, and I will say what it outputs. Okay. When you execute SQL statement that don't return data, like insert, update, and exit, returns, you can type the exec function runs SQL code. It returns database rows as arrays of objects like blah blah blah. When you execute SQL statements that don't return data, like insert and update, exec returns empty array. Ah, okay. So this is the first mistake I did, and I thought that the SQL will return the empty array. That's not true. The exec will. You can type error without the quotes if the code will result in an error. Alrighty, understood. Maybe I can put it a little bit higher. The notebook. I can see better. Okay. It's crooked. No, it's not. So, the next thing is to do this guy. So, we are creating a table of people. Have ID and name. This is injury primary key, not null. And we are inserting into those things. So, primary key, not null. So, it will get us two records, Amir and Betty. And this one I believe will be one, or at least I hope so. And name will be Amir. And then we will have the second one with which one has a value of ID, which will be 2, and name, which will be Betty. And I'm correct. I'm so relieved. Right. Oh, it's smooth. Yesterday it was like these boxes, and now they changed it. Huh. So it looks like they still working on it. Right, find user function that finds a user by their ID. Return the object itself, not the full query result array. If no user is found, returns JavaScript null. You can check for weather, and the query returned no results with if and this condition. Okay, so we'll do that. So we want select select everything from users where ID equals question mark. I'll do one in here, and the first argument will be ID. So we'll close this query, and now we will return. And here we will have a ternary operator. So we won't return null if it doesn't find anything. So if query result at length is equal to 0, it will return null, and otherwise we will just return the query result. Result, and we want the first object of it. Okay, and now I can close the function, but make it more beautiful. Like so, that should be it. And it is not. Why? Missing closing parenthesis. Where? Oh dear Lord. I did it again in here. Okay. This quotes should not be here, this quotation mark. Okay. Use semicolon to create a users table with a text name. Then insert a user named Amir and finally select the user back out. Let's do it. So one statement. So create users name, which is text, and then insert into users. We will be inserting the columns name and nothing else, and the values will be Amir. Okay, and then we will select everything. So select star from users, and we are correct. Nice. Next one. Select one, select. Okay, so this one results in error. I cannot use the bind and the semicolon in one SQL expression, at least in here. So it will do error. That is what we'll do. Now take second chance and review items that you missed the first time. Thank you, sir. That is this one, and what I did extra quotation mark. So what we want to do. Okay, so we'll select star from users where ID equals that guy, and we will say ID. Okay, close that, and here's the comma, like so, and here is not this. Okay, and now, oh, and that is why it tabs like so. I see. Okay, now it makes sense. And then I will do the same. So return result one equal 0. Then no, otherwise query result. The first one, you, and we'll close the function, and now we are correct. This nice. Okay, and we have some lessons to learn. Yay! Okay, let's go. When selecting from a table, we can select expressions computed from the table's columns. Okay. Age plus 1. Okay, I think I saw this one already. So it will do this. So we will have a age that will be free. Then we have age next year, and that will be 4, and we can close it. And that's it. Yeah. In JavaScript we can I kind of feel that I already went through this lesson. Oh well. In JavaScript we can concatenate strings like A plus B. In SQLite we can concatenate with A pipe pipe B. This syntax is unfortunate because pipe pipe means OR in the most other languages. In SQL, OR is simply OR. Okay. So it is name the cat, so it will return this, and that will say Mrs. Fluff and the cat, and that should be it. No. Oh, name as name like so. I forgot the field name. A select can never change the data in table, so doing this doesn't modify Mrs. Fluff. That frees us from worrying about mistakes in our selects. They might return the wrong data, which would be bad, but at least we know that they won't damage the tables, which would be worse. Okay, agreed. SQL dialects tend to have more built-in operators than other programming languages. For example, most programming languages have greater, lesser, greater equal, and lesser equal. SQL has those too. But most SQL dialects also have a special between operator. In SQL, instead of SQL, instead of greater, we can say between x, between epsilon and z. Okay, so it is x is between y and z. Remember that SQLite represents true as 1 and false as 0. So now what we are doing, we are creating a table, cats, with two fields, name and age, text and integer are the types, and we are inserting two rows. One is Mrs. Fluff with age of 3, and the second one is Katy Perry, which is already 5. Okay. Select name, age between 2 and 3 as... Oh, I know why. I was stuck on this lesson. I could not go through it because it might have been broken or I was doing something wrong. So we'll see. So we are selecting name, and between 2 and 3 inclusive. So it is Mrs. Fluff. And now the second part, and that will be The is 2 or 3. That will be 3. Is that? Mm-hmm. Alright, what the hell is happening in here? Select image between 2 and 3 as is 2 or 3 from cats. What what am I doing? What am I doing wrong? Okay, so here they are saying remember that SQLite represents true as 1 and false as 0. So I'm guessing like it will. Okay, okay, I thought, okay. Now I get it. So this is true. And for the second cat, which name is Kate Pore, uh, the field is 2 or 3, will be false. Close the object. And that's the right answer. You whoop whoop. That's cool. That's pretty nice. All right. Most programming languages, the at and in x between y and z is an interesting example of SQL syntax. Normally, and in SQL is a logical and, like ampersand ampersand in most programming languages. Select 1 and 1 returns 1. Select 1 and 0 returns 0, etc. SQL has tendency to reuse keywords, which is happening here. When we select between Y and Z, the AND is part of between. It has nothing to do with the logical AND of select X and Y. We can we can think of this by analogy to JavaScript syntax. In JavaScript, objects like uh, the first one, a colon separates the property from its value. JavaScript, which switch statements, we can say K6, blah, 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 marking the clause. Both of these are using the same colon character. but it means something different in each context. Yeah, sure. So now you are apologetic. Now you are apologetic for SQL language, are you? Similar thing is happening with and in SQL can be either logical and or part of in between. Yeah, sure, whatever. SQL is making a trade-off that doesn't exist in any popular language created since 90s. It's using huge numbers of language keywords instead of providing functions. Huge numbers of language keywords instead providing functions. Okay. In JavaScript, most functions are required or imported from third-party NPM modules. In Python or Java, which have strongest standard libraries, a lot of functions come with the language. In SQL, many functions aren't functions at all. They are syntax of the language itself, like X between Y and Z. This is why JavaScript has 64 keywords, but PostgreSQL SQL dialect has 760. Wow. Okay. I want to see. It takes kind of long to load it. I don't know. SQL keywords alter begin character length. Oh, that's a really lot. Okay. Something has like this reserved, non-reserved fields. PostgreSQL, SQL. Okay. So what is this? Non-reserved SQL, Postgre. Okay. So select two values from the cats table. First, the cat's names with the cat appended to each. Second, is 3 years old, a boolean represented as 1 or so 0 or 1 is SQLite. Remember that equality conversion in SQL is equal, not equal, or 3 equals. Okay, so first the cat's names. Okay, select uh, name, name, uh, and I will append the cat as name. The second one will be is 3 years old, and that will be age equal 3 as 3 years old from cats. And that should be it, and it's not. And near is. Okay. Huh. Now it's good. I don't know what happened in here. So, what do we have next? We finished the lesson. That's what's next. On conflict update, and there's a SQL injection. 28 minutes. Let's go. Imagine that we want to track how many times the cats have been groomed. If a cat has never been groomed, no row exists for them. However, a cat is groomed, a row is created or updated to reflect how many times they've been groomed. Using the SQL features that we've learned so far, this will be awkward. First, we query the table to see whether any groomings records exist. If it does, we update it, otherwise we create a new one. In this example, our first call to the groom will create the groomings row. Then the second call will notice that existing row and update it. Oh, that's long. Okay, so creating table groomings. This is integer primary, so ID, cat name, and count. Then we have a function in here which says groom, and there's a cat name. So groomings, we will select everything from groomings where cat name is equal to this. So we have a groomings. If it's 0, we will insert it in it, and that's it. Cat name 1, sure. If we don't get anything bad, we will take the first result and then we will update it, and we will. Okay, so there's the grooming count. Okay, so where does the grooming? Oh, it comes from here. Grooming count for +1 and grooming ID. Okay. What is the grooming ID? Ah, here. I see. I see. Understood, understood. Groom, Mr. Fluff, groom, Mr. Fluff. So now, if we select the cat name for Mr. Fluff, we will get. Okay, so we are selecting cat name, and that will be our Mrs. Fluff. And then we have a count, and that will be 1, 2. Okay. We can do this in a much more natural way. There's already a unique constraint on grooming's cat name column because we only want to maintain 1 row per cat. If we try to insert 2 rows of the same cat, it will be an error. Okay, that error is good. It shows that the unique constraint is working. We can use onConflict to use the error to our advantage. We'll tell the database if the insert conflicts with an existing record's cat name to increment the existing rows count instead of erroring. Ah, sounds good. Here's an isolated example of that. Look closely on conflict user ID. Do update set count equals to count plus 1. And it knows already that it has to do the thing on the same row, right? When the cat name that we are trying to insert violates the cat name column's uniqueness constraint, update that existing row by incrementing its count by 1. Hold on. Alright. So we are doing what in here? We're creating the groomings as ID cat name count that we are inserting into groomings. Okay, and then we are doing the same thing, but we have the on conflict resolution. So on conflict cat name. Okay, so on conflict, and then you specify what conflict is it on. Okay, on conflict, which column do update. Huh. Do update set. That's interesting wording, but okay. Do update set count equal to count plus one. So now we will have Mrs. Fluff with two breedings. So Mrs. Fluff, Your Majesty, has been groomed twice, so count, and that will be two. What? Yeah, cat name. That is correct. Now we can write better version of our groom function. Instead of retrieving the row and using if to decide what to do, we'll use an on conflict. That way, the database already knows what to do if the row exists. Sure. Write a better version of the groom function. When a cat is groomed for the first time, the record should be inserted. After subsequent groomings, the record should be updated. Use onConflict to update to do both of those in a single insert statement. Okay, so we are inserting in the groomings name count onConflict cat name do update set count equal to count plus one. That should work, right? And it does! Da, 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 da. Okay, so what they are writing now. This new version of Groom is much simpler than our original. Indeed it is. Indeed it is. There's no conditional, and we've replaced a trio of select, insert, update queries with a single insert on conflict query. The new version is also more efficient. Our original version had to go to the database to retrieve the grooming count. Then it had to make the decision and go back again to update the count. The version is a single statement that hits the database only once. That's what I've heard somewhere as well, that you should write queries that you would have at least transactions, meaning the hitting the database. That is more efficient for some reason. Which I don't know what the reason is, but okay. I kinda trust it. Alright. So where were we? The new version, blah blah blah. The new, which one's the new? Okay, the new version is also safer. In the original version, there's a small time delay between retrieving the grooming count and updating it. During that brief window, a groomings row could theoretically be created, and if that happens, then trying to insert a new row will fail because it will violate the constraint. True. That may sound very unlikely, but when an application is at scale with millions of users, unlikely things become likely. This is how applications end up with weird errors that happen once per month and are very hard to debug. Yeah, that's awful. Because the version is a single statement, because the new version is a single statement, that dangerous doesn't exist. Our insert dash dot 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 on conflict will either create or update the record as a single atomic operation. But you haven't told me what atomic operation is. Like, I happen to know, but I would be screwed if I don't. And that is the end of our lesson. So, and we are 9 minutes now over our set time period, so that means we are done, and done is better than perfect. So, let's end it in here. Bye.